Hey everybody, today we're going to talk about linear regression. Specifically, we're going to use technology, which means Excel and Desmos, to help us find the line of best fit for a given set of data. Linear regression helps us analyze how variables are related. That might mean how study time relates to better grades, how a marketing campaign changes revenue, or how a prescription medicine might lead to weight loss. In our first example, a company wants to understand if the amount of training provided to its employees has an impact on their productivity. The HR department collects data on a sample of 10 employees, recording the number of hours of training each employee spent over the last month, and then looks at their corresponding productivity score. We're going to take this data and put it into Excel. The first thing we want to do is make a graph. We'll highlight the data, we'll hit Insert, go to the charts, and pick a scatter plot. Then from here we have two choices. You can click the plus sign, check mark trend line, then click the arrow for more options, where you can scroll down to display equation on the chart. From here, you can move the chart and then increase the font. The other option is to right-click on the data points, then you can add a trend line, and again, go down to display equation on the chart and change the font. The equation y equals 3.0121x plus 39.509 tells us that we have a slope of 3.0121 and we would have an associated intercept at 39.509. From here, we can plug in values of x and it will tell you the predicted value of y. Let's again copy the values and paste them into Desmos. I'll hit zoom so you can see the nice scatter plot. And this time, I'm going to type y1 is approximately mx1 plus b. The x1 and y1 tells Desmos to look at the x1 and y1 columns and come up with a line of best fit for the data. We get the same slope and y-intercept for the data, and this time we could easily type in a number like 2 times m plus b. Desmos knows what m and b are from our previous step and automatically plugs in the value to make the prediction for what happens at the data value of 2. Our second example says a restaurant owner tracks the value of a commercial oven for 6 years to understand how its value depreciates. Again, we're going to take this data and put it into Excel. We'll highlight all the values, click Insert, Chart, Scatter Plot. Either use the plus or right-click to add the trend line. Click over to More Options, where we'll display the equation on the chart. In this example, we can see we have a negative slope that corresponds to decreasing values for the data. When we go to Excel this time and copy the information and hit Ctrl-V to paste, we run into a little issue. Our first line should be 0 for x1 and 10,000 for our y1. Instead, we have 010 and 000. This problem occurs because of the comma in our original data. Let's go back to Excel to correct this problem. I'm going to highlight my values for y1, right-click, Format Cells, and unclick to use the 1000 separator. Now I can highlight all the data again, copy it, and in Desmos I will paste the values, and this time I have the correct values. I can see my nice declining line. To get the line of best fit, I type y1 is approximately mx1 plus b. The approximately sign is on the upper left-hand corner of your keyboard, and you can also open the keyboard in Desmos, click over to ABC, and look on the bottom rows of keys. The subscripts of x1 and y1 will happen automatically when you type y and 1 together and x and 1 together. If we want a projection of what the value of the oven will be in year 9, I can type 9M plus B, which gives me $3,279. It's up to you whether you use Excel or Desmos to come up with the line of best fit. In our next video, we'll talk about correlation to talk about the strength of the line of best fit.